Well, hello and welcome to this video session. I do want to discuss this upcoming class, Management 340. I'm not going to go into a lot of detail with reference to Moodle, as we will do that in class. But what I am interested in is having a discussion with doing some preparatory work that I believe, if you're not familiar with Excel, will pay great dividends as we move into this class. What we're going to find out is that we're going to use Excel as the tool to which to improve our critical thinking and problem solving skills. And that's really what this class is about. But we'll use Excel as the tool to do that. So with that in mind, I'm going to see if I can't pause this just for a moment and get my screens reconfigured, because I really want you to see the screen that I'm going to be using. So stand by just for a moment. Okay, we're back. So hopefully you can see my screen now. And where I'd like for you to go is to a website called www.excel-easy. www.excel-easy.com. And you can see I already have it pulled up here on a Google search. And this is what it came up with. www.excel-easy.com. So we're going to click onto this. And when it comes up, what you're going to see, this is an Excel tutorial that is self-driven. It's for Excel 2010, but if you're using Excel 2013, it will work for that as well. Some of the functions are very similar. Now, if you're using Google Sheets, I'm not that familiar with Google Sheets, so you may have to do some touring around to see if Google Sheets will have a solver function to it under data analysis, but we'll get to that. I know Excel does, but I've never really searched it out enough to say if it does that with Google Sheets or not. So just bear that thought in mind. But again, we're going to be using Excel exclusively as the tool to which to improve our critical thinking and problem solving skills. And that's really what Management 340 is all about. So if you're not familiar with Excel, then you may find this helpful. If you are familiar with Excel and already have it loaded on your machine, then please bear with me just for a few moments. But this Excel, it starts out, as you can see up here on the ribbon, with different functions. Now, we're not going to worry about visual basic analysis here. That's something that if you're doing a lot of macros, which is good to know if you're doing macros, it's not something we're going to be doing in our class. But this really starts out with the basics. It talks about what is a range, and we're going to use range names a lot in this class, and formulas and functions. So you can see it does a lot of different things. What's a template? What are some of the keyboard shortcuts? Some of those type things. So it goes into a lot of different topics, which aligns itself with the ribbon bar. So if you're not familiar with Excel at all, then start here with the introduction. In the introduction, it tells you some of the ranges and formulas and functions. And they give you here on the right-hand side of the screen some additional activities or hyperlink that you can go to really reinforce and give you some very good examples. And some of these formulas and functions we will be using in our class. And again, they even give you more information over here. So, and I know I'm scrolling through this fast, and not the intent for you to read my screen as much as it is to load it up on yours so that you can see it, again, if you're not familiar with it. It goes in some of the basics related to how when you open up a workbook, in Excel, you have multiple worksheets, and it takes you through some of those specific terminology that Excel uses. Again, it gives you some very good examples here. Call up the ribbon. And this is what the ribbon looks like, and this is the name box. This is the formula box, and these are individual cells. on this one entire workbook with this first worksheet. So it goes into a lot of that information as well. And let me back up here just for a moment, because it also shows you if you don't have Excel loaded on your machine, especially data analysis, and I think I want to look here. So let me continue on. I'm sorry. I just got sidetracked. So the basics, gives you some of the basics of the Excel worksheet, some of the specific functions, especially when you get into counting and using logical expressions. Also how you have some formulas, and even gives you some good troubleshooting techniques, the thing called formula errors, which you will want to make sure you review that, because building Excel models for linear programming, you may run into some error messages, and this just gives you some tips on what a pound sign name means, a pound value error means, division by zero error, what all that means in a reference area. So it's just a good tool to which to get you familiar with some of the error messages that you may face when we start doing the linear programming. Now, I've said all that to get to this called data analysis. And this is where the data analysis is where we're really going to get into the beef of this discussion, because we're going to be using data analysis a lot in order to do our linear programming model. Under the data analysis, what I'm really interested in is the solver piece. That's what we're going to use exclusively for our class. Now, the analysis tool pack, if you have not had statistics yet, or if you're thinking to take statistics, the analysis tool pack is a good thing to load up on, if you not already have it, loaded up on your Excel program as well. And both of these are add-ins to Excel. If you have Microsoft Excel, then that was already included into that program. It's just a matter of loading that up on your computer. So, but I want to really focus here on data analysis, and we're going to talk about solver exclusively today. So when we call up solver, it's going to tell us how we actually load solver into our machine. So it says load the solver add-in. So the first thing we're going to do is we're going to hit Excel options. We're going to hit Excel options, then we're going to go under add-ins. And when you scroll down under the add-ins, we want to look in for solver add-in. And once we hit solver add-in, we want to make sure we have Excel add-ins highlighted here in this drop-down box. And you want to hit the word go. You don't want to hit the word OK yet. You want to hit the word go, because that's going to take you to the next dialog box, which is going to have the add-ins that are available to you. And this is where we want to click on and make sure we have the check mark in the solver add-in box. Now, I said earlier the analysis toolpack, that's used a lot. You could use that for statistical analysis, financial analysis, just a lot of different analysis that you will find some of the functionality in Excel. If you don't already have it loaded, go ahead and click that box as well, because both of those would be useful for you in your academic career. But for what we're trying to accomplish, we really want to focus on solver add-in. So once we highlight solver add-in box, now hit OK, and over on the right-hand side of your new worksheet that's open, or workbook that's open in Excel, and I'm going to pause here momentarily and go open up my Excel so you can see what it actually looks like. You're going to see this thing under the analysis, under the data tab, this thing called solver under the analysis section. So let me pause just for a moment and go open my Excel so you can see what it actually looks like in Excel. Okay, so I'm back and I have Excel starting to open, and I'm going to go to a blank workbook. And in that workbook, this is what Excel is calling an entire workbook. this entire thing. And it typically defaults to a book numerical value. But as you know, if you save it, you can rename it and you can save it into any, give it any name you want. So that becomes the name of the workbook. Now, this is a workbook that we're calling Book 1, and we have one worksheet. But maybe I want to add another sheet and another sheet, and I can come in here and name these different worksheets as well. But what I really want you to see, based on that previous video, that once we went to File, Options, and I wanted to go to Add-ins, you can see for, this is Excel 2013, it's a little bit different. I wanted to go to Manage Excel Add-ins. Some of this is different, but the concepts of getting there is still the same. And when I hit the word Go, you can see I already have Analysis Toolpack and Solver Add-in loaded on my machine. So I'm not going to reload it, so I'm going to X out of that. But if it was not there and I clicked those for the first time and hit the word OK, when I came back under my Data tab, over to the right-hand side, you'll see where I have Data Analysis and Solver both loaded on my machine. And again, for what we're trying to accomplish, we're going to focus a lot here on Solver. So let me go back to the Excel Easy. Okay, so I'm back here on Excel Easy. So this is what I just showed you that was on my machine, but I had the data analysis pack as well. So with Solver in, Solver gives us the ability to make managerial decisions based on the set of criterion that management team has given us. And they're going to give you quite a few examples that you can work through. And I'm not, excuse me, please don't focus on the terminology so much yet about what's a constraint and what's a changing cell, what's a data cell, what's an output cell yet. We will discuss all of that in class to great detail. But what I'd like you to focus on is to see how it's working, see what it's doing. And what this is, they give you these different color formats, and these formats here follows pretty closely to what we will see in our textbook as well. The yellow means what's the type of decision that's got to be made. The light turquoise are the constraints, and anytime you see an inequality sign less than or equal to, or greater than or equal to, or equal to, you have the left-hand side of your constraint and the right-hand side of your constraint. So we're trying to make a decision on how many different orders of bicycles, mopeds, and child seats we need to do based on the capital that we have available to us and the storage capabilities that we have to us. And this is the available resources. Then we have this thing called our unit profit. So if I sell one bicycle, if we order one bicycle and sell one bicycle, then that's $100. And if I order and sell one moped, that's $300. One child seat and one child seat, one order and sell, that's $50. So if I was to take the product of this row times this row and sum all that up, that'd be 1 times 100 plus 1 times 300 plus 1 times 50, which would equal $450 total profit. And I just said that, and Excel gives you this great function called sum product function that will calculate that for you instead of saying this cell address times this cell address plus this cell address times this cell address plus this cell address times this cell address equals $450. But we'll see all that as we move forward throughout our class. But this just tells you the total profit or the objective function. And again, don't overly concern yourself with the terminology that I'm using because we'll get into that. But this is the overall measure of performance. And the overall measure of performance is to maximize my resources, but yet not exceeding my resources, and to make as many orders that we possibly can to maximize our profit. So that's called the overall measure of performance of these decisions. And they also use these things called range names. Range names is, in this particular model, is relatively, they're simplistic from the standpoint, it's not overly complicated. The calculations are not, it's not doing a lot of significant calculations per se. However, using the range names, if there's some terminology here on the range name that's important. You see unit profit. Then the range name in this legend or table, you will see that a lot, and that's pretty consistent throughout our Management 340 textbook. Almost every one of these models is going to have a legend. The legend in itself is not doing any calculations. It's almost like a table of contents in a textbook or a novel that you may read. So this is considered the table of contents, or we call it a legend, with reference to, I can find in cell C4 through E4 this range name called unit profit, which is C4 to E4. So this range of cells is given this range name called unit profit. And I have to highlight all three of these cell addresses to be able to see the unit profit. And again, we will get into that as we get into class. But so a few things here. Unit profit, two major words, no space, with each first letter capitalized. Same thing in order size, same thing in resources used, and you can see how that is working with the other two. So anytime you're using multiple words in a range name, each major word is capitalized, the first letter, and there's no spaces in between. Now, Excel also gives you this great function where, and let me come here to a worksheet, where if I wanted to see what my formulas are in a particular cell address, well, obviously I can highlight that address. And let me pause again and go get an actual working model for us. Hold one second. Okay, this is an actual working model, and this one looks a little bit busy, but this has a lot of the nomenclature that we'll see in class. So let me focus here. Don't overly concern yourself with this stuff here yet, that you see all these different things in the stuff that I have here. Let me focus here. What I want to show you is that up under the data tab, the formula tab, show formulas, what that will do is when I click that, that's going to show me the actual formulas that you see here in the individual cell addresses. Now I can do that by individual cell, and I can see the actual formula, or if I hit show formulas, then it's going to automatically show me what formulas are in each cell address and what they are doing. So that's a good troubleshooting technique that you can use to look at what's in your specific cell addresses. And here's the legend we talked about, and I have hours available, which is this cell address G7 through G9. This is our formula bar. This is our name box here on our Excel worksheet. And you can see that it is total profit. So if I click into any one of these cells, when a range is defined, you just get the individual cell address. But a range name, by its meaning, means it is a range of cells. And when I highlight that range of cells, you see how the name box now populates with that range name. So that's what this is saying. So what we're going to learn in our class, again, this thing in orange is called the objective cell, or the overall performance of measure. This stuff that you see that's highlighted in blue is called data cells. This that has no color is called output cells, and this that's in yellow is called changing cells. And you're going to see that consistently throughout our textbook. And this is the left-hand side of the constraint. This is the right-hand side of the constraint. So, and again, we will discuss a lot of this in great detail when we get to class. So let me come back to our Excel worksheet. So they give us this example, and you can see they work it out for us. And the beauty that I like about this is it goes into detail of setting up Solver and what Solver is doing. So let me, as this one shows you as well, it gives you a step-by-step instruction of setting up Solver. And I'm going to show you how to get to the Solver parameters back on my Excel worksheet. But in this Solver parameter, it's talking about setting the objective, which is the orange cell we call the overall measure of performance, or total profit. Because we want to maximize the total income, that's the reason why this is a maximization problem. And the changing cells, or the yellow cells, is the order size. Then we talked about these subjected to the constraints, or that left-hand side of the inequality sign and the right-hand side of the inequality sign. And what this solver parameter is really saying is that I want to make sure that I maximize my profit based on my order size, but I cannot exceed what resources that I use. There's got to be less than that my resources available. Then we're going to make these constraints non-negative by making sure that box is checked, which indicates that I've got to produce at least one, or order at least one of each, or one for the model, because not making something means negative profit, and that's not the intent. So that's the reason why it's non-negative. And we're going to be using the simplex LP. So once we have all this in, we're going to hit this thing called solve. And once we hit the word solve, this is how, before I hit the word solve, let me continue here, because this is how we're setting up, and I'm going to show you that momentarily. Now, once we hit the word solve, you should get this dialog box, which indicates that the solver parameters, all constraints were satisfied, and then you get the optimum solution of the objective overall measure of performance. So I know that's very quick, so I'm going to go back here momentarily and show you again the actual spreadsheet. But the other thing I want to discuss with you here, when we go under the data analysis under Solver, make sure you get Solver loaded up on your machine and go to Solver. Actually, I'll go into Excel, put in some of this data, just like you see it here. Practicing with getting the colors would be a good thing, but Excel doesn't care what colors you use. Excel is not calculating on colors, it's calculating on numerical values. But what you'll find is that if you remain consistent with the color scheme, that will help you immediately identify as you're building your particular models. Another thing I want to talk to you here about this Excel-Easy is that they also give you some good examples to work through. And I would suggest work on the transportation problem, the assignment problem, the shortest path problem, and the maximum flow problem. Just work on those four, because that's really going to reinforce how Excel is using Solver to make management decisions. So let me look at one more transportation problem. And this is what the transportation looks like. So your goal and your practice would be build this model. Build it the way you see here. Focus on the labels and try to get it as close to it as you possibly can. And as you're doing that, go ahead and build your legend and identify where the range names are at, and go ahead and when you're back up here under the basics and the function, it's going to show you how to create a range name. Go in and practice doing that as well. Practice putting in your formulas and try to look at that and ask the question, now why is that a sum? Why is this a sum product? And as you read that material, I think it will become self-evident to you. And actually come in and put in the parameters in solver, just like you see here, very same way, and solve and see if you get the same solution. So practice with that and get familiar with Excel. And do not stress out if you say, I don't quite understand it, or I didn't quite get the same answer. That's fine. You can always send me an email at mward@umo.edu if you like, and I will help you get that solved before our class starts. But this is not graded material for you. It's just in order to get you familiar with Excel prior to the class. Because what I've seen is the ones who struggle the most in this concept are the ones who's trying to use Excel, never used Excel before, trying to learn the class material and trying to brush up on some of their basic algebra skills all at the same time. So the more you can get done prior to class, I believe the more success that you're going to enjoy, and certainly the lot less stress. So practice with these four and let me know if you have any questions. So let me come back here to our Excel model. We're almost done, so bear with me. But there's one more thing I want to show you before I conclude this video. So this is the Excel model. This is what, as you can see, the colors that we use. Now your textbook, because your textbook that we're using is the 5th edition of Introduction to Management Science from McGraw-Hill. Our textbook is in black and white, so you're not going to see these colors per se, but what you will see is that the textbook is giving you various shades of gray. Like when you get your textbook, you're going to see this is going to be dark gray. This is going to be a lighter gray, and that's going to be a shade of gray between dark and light, kind of a medium gray. And that it will look just almost like that gray here. That's what you'll see in your textbook. But if you were to go to McGraw-Hill's website, and let me go there real quick. Let me see where I put that at. Here it is. Okay, our textbook has a website for students. It's called MHHE, Mike Hotel Health Hotel Echo.com, Hiller, HILLIER 5E. And when you Google that, it's going to take you to this thing called Information Center, hopefully. And when we click on that, it's going to take us to the student edition and the instructor edition of our textbook. So what we're interested in is the student edition. So when you click on that, it's going to bring up some information with reference to our text. And some of this information up here is just some supplemental information. But what I'm interested in is, and I know that in chapter 2, if I remember correctly, is where we start with our textbook spreadsheets. These textbook spreadsheets are the very same Excel spreadsheets that you will see in your textbook. And when you're using and reading your text, what I found to be most helpful is to come in here and open up these spreadsheets so that you can have the opportunity to, as you're reading your textbook, to come in here and manipulate these spreadsheets as the way they're manipulating it in the textbook, and that will kind of reinforce. Now, if you buy a new textbook, that should come with a CD that has all these spreadsheets in it. But if you do not if you rent a textbook or if you buy a used textbook, you could go to this website, and each chapter has these textbook spreadsheets associated with it that you can download to help you in your learning and reinforcement of this material. Now, the spreadsheets is not a requirement per se. You don't have to have these spreadsheets, but I found that because you could build them all from scratch, but I found them to be somewhat useful and to re-enhance the learning. But don't stress over that either. We'll discuss that more in class. But I did want to expose that to you, that getting copies of these spreadsheets, I believe, is very helpful as you're learning this topic. And you can either get them from the McGraw-Hill website I showed you, or if you bought a new textbook, it'll come with a CD. So let's return back. This is a clean copy of the window glass problem that's directly from our textbook. And as you can see, they follow the very same nomenclature. They use the range names with the legend. They use the same color scheme. So let me get rid of, we're starting with something blank, a blank workbook, excuse me, a worksheet. The blue cells is data cells. That data does not change unless I physically go in and change those values. The changing cells here are in yellow. This is what Solver is calculating in the backgrounds for us. This is a sum product function that I'm looking at the number of doors times the per plant of plant 1, plant 2, plant 3, and the number of plus the number of windows times plant 1, plant 2, plant 3, and that's what is being put here in these individual columns. The total profit is the number of doors times the profit plus the number of windows times the profit that's being produced. The left-hand side of the constraint cannot exceed my hours available on the right-hand side. So this is the number of hours that I have available per plant. The goal is what's going to be the best mix of producing doors and windows that's not going to exceed my hours available based on my constraints, but yet that's going to maximize my total profit. Now we could use what-if analysis and try to say, well, let's do 1 and 1 and see what happens. Well, you can see the model says I'll make $300 and I'm not going to exceed my constraints. But that's not maximizing my profit. So let me try a different scenario of 4 doors and 1 windows. So now you can see that I make more money and I still did not exceed my hours available. But look what I'm leaving on the table. I'm leaving almost 10 hours of plant 2 productivity that I'm not using. I'm leaving 4 hours of the combination of plant 3 on the table that I'm not using. So that's not the optimum solution either, because I'm still making money, but yet I'm not maximizing the capabilities of my plant. So let's try one more scenario. Okay, now one more scenario. I still did not exceed any of my resources, my hours available, but I'm not maximizing the full capabilities of my plant. Even though I went from $1,700 to $2,200, I'm still not there. But you can see how doing what-if analysis by changing the variables here will make the model work. But what Solver does for us, under Data, Solver, it will go out and it will do all these iterations for us, and it's going to come back with the optimum product mix that's not going to exceed our constraints while maximizing our profits. So what you saw back on the Excel-Easy was that the set objective is going to be the total profit, which is this cell address here. And if it was blank, so let me make all this blank so you can see exactly how to go in and put that in. So when you first build a worksheet and you open up Solver, this is what you will see. So we know the set objective is our overall measure of performance. So I'm going to highlight that cell address, and you see it's going to populate it with the cell address. But once we solve it and come back into it, it should return back to its range name because we define that as total profit. So if you see the cell address, that's okay. Initially, when you come back, if you have your range name identified correctly, that will auto-populate that. Because we know this is a maximization problem, we want to maximize profit, we make sure that radio button is highlighted. Now by changing cells, the changing cells is typically what you will always see in yellow, which is the units produced in this case. Now we're subjected to the constraints of hours used and hours available. So I want to add. So my cell reference, left-hand side, right-hand side. My cell reference is going to be these three because I'm using the same inequality sign. So I'm comparing hours used to hours available. That's the reason why I'm highlighting all three. You could highlight one at a time and put in three different constraints, but Excel recognizes that you're doing that by highlighting all three cells at the same time because of the inequality signs are the same. So I'm going to verify. You see I do a drop-down menu here that it's less than or equal to. Then I'm adding the right-hand side of my constraint. So I have the left-hand side of my cell reference constraint, my inequality sign, then my constraint on the right-hand side, which is my hours available. Now I'm going to hit the word add. Excuse me. If I only had, this was the only one I was going to use, I would hit the word OK. But what if I had another constraint that was not listed here, which you will see that, I would hit the word add and add that constraint. And at the time I had all my constraints in, then I would hit OK. OK, now you see what just occurred. You see our range names returned, which is fine. Unconstrained variables, non-negative, because if you're producing negative values here, you're not going to make any profit. So we're telling the model, ignore any negative values. We're using the simplex method, and we'll discuss that more in class when we get there. So just make sure it's simplex method. Now we're going to hit the word solve. Solve comes up and it tells us that we have a solution and all constraints have been optimally satisfied. So what that is saying is that I have a solver in the background doing all these iterations for us where we were trying to pick and choose different what-if scenarios. It came back and told us that if you produce 2 doors and 6 windows, you're not going to violate your constraints and you're going to maximize your profit. And as we see here, the only plant number 1 is 2 hours short, but yet I'm maximizing plant 2 and I'm maximizing plant 3. So this combination assures us that that's going to be the maximum profit that we can make. And we didn't have any error messages here, and we'll talk about some of those different error messages that you may see in building some of those models. So Excel gives you a lot of information. It's just a matter of interpreting that information. So now that we're satisfied, we'll hit the word OK, and there is your completed model. So we went through all that. We went through using Excel Easy. We showed you how to find the Excel spreadsheets on the McGraw-Hill website. And we went through an actual problem. And this window gas problem will be one that you will see a lot. It's kind of modeled almost all the way through the entire textbook. So understanding some of these basic concepts, but the biggest thing, these basic concepts, again, we'll discuss a lot in class, but the biggest thing is get yourself familiar with Excel. Get your machine up and running with reference to the solver and kind of play with some of these models. Again, don't overly focus or overly stress on if I got the right colors or I don't understand what Dr. Ward was saying the purpose of a yellow, changing cells, or the left-hand, right-hand constraints. Don't stress over that. We will go over all that in class, but the important thing is getting your Excel working, getting comfortable with it, and understanding some of the basic functions. The last thing I want to show you, we talked about range names. The range names for these earlier chapters is you could do it without range names, but I think if you go ahead and learn how to use range names and how to make range names, you're going to find that much, much easier when we get into some of the other chapters. And it's certainly going to aid in your troubleshooting techniques. So I'm just going to come over here and I'm just going to add in some values so that you can see what a range name looks like. So I've added these 3 cell addresses, and you can see that up in my formula bar and in our name box, we just list the individual cell addresses. But I want to define these 3 cells as a range. So I've highlighted my 3 cells, and anytime you're dealing with Excel, wherever your cursor is at, that box is highlighted. This rail bar here, that's going to be an important function for you where I can highlight and move and copy the same formulas. But we'll get into that in class as well. So I've highlighted my 3 cells. Come back over here to my name box. So you see I clicked into it, highlighted it. Now I'm going to put in a range name called Ward Test 1. And when I hit enter, you see that now stayed in my range on my name box. So when I click on individual cells, you can see up in our name box, the Ward Test 1 is not there. But if I highlight the range of cells, you see Ward Test box is there. So that's kind of the simplistic way of doing a range name. And you see, because I use 2 major words in a numerical value, there's no spaces in between each one. So that's a brief synopsis of what you can have coming to you using linear programming. Again, we're going to be using, this is a linear programming model. It really is, this whole class really is about developing your critical thinking, analysis, problem solving skills. And we'll just happen to be using Excel as the tool to which to provide this information as we build these skills. What you're going to see is that this class is going to be work. You're going to have to roll up your sleeves. The best way to reinforce this material is to do homework, and we have some homework. And we'll, again, talk about that a lot when we get into class. So if you have any questions before class starts, please give me a call or send me an email. Again, my email is nward@umo.edu, and my cell phone number is 910-512-1739. Thanks and have a great day.